In electricity chapter, usually children often have doubts on the combination of resistances. Some of those, why does resultant resistance in series combination is more? Why does current same in series combination of resistors? Why does the resultant resistance in parallel combination is less? Voltage same in parallel combination. Why? Let's try to find the answers for these questions. Before we answer these, let's go to the combination of resistances. There are two basic combination of resistors. One among the combinations is series. So what do you mean by series combination of resistances? I mean, when do we say resistors connected in series? Whenever resistors connected end on end, they are said to be in series combination. Consider three resistors R1, R2 and R3 connected end on end, and that combination to the ends of a cell. End on end. Connecting resistors are said to be in series combination. Whenever connected resistors in series combination, it creates a single path. series combination creates a single path for the charge flow. It makes no alternate path. For current so same current through all the resistors. But voltage divides. Let V be the voltage by the cell causes the current I. V1 across R1, V2 across R2, V3 across R3, then V is equal to V1 plus V2 plus V3 as V divides as V1, V2, V3. Let R be the resultant resistance of the circuit. Apply Ohm's law across the ends of the cell. That is equal to V is equal to IR. V1 is the voltage across R1. According to Ohm's law, V1 is equal to IR1. V2 is IR2. V3 is IR3. IR1 plus IR2 plus IR3. IR, that is I of R1 plus R2 plus R3. Finally, resultant resistance in series combination is sum of the individual resistances. Next, second combination of resistances is a parallel combination. consider 3 resistors R1, R2, R3 connected between 2 common points. And at the common points, the 2 terminals of the cell also connected. Whenever resistors connected between 2 common points, they are said to be in parallel combination. In this combination, terminals of the cell and terminals of the resistors common. I mean, positive negative ends of the cells are connected at the points where all the resistors are connected. So, voltage across the cell, same it is applied across all the 3 resistors. In parallel combination, all the resistors connected directly to cell. So, same voltage taken across all the resistors. But charges find alternate paths. So current divides. Let I be the current by the cell, flows through the circuit. I divides through these 3 paths into I1 through R1, I2 through R2, I3 through R3. In parallel combination, as current divides, it can be written as I as I1 plus I2 plus I3. Let R be the resultant resistance of this combination. Apply Ohm's law. I equal to total current in the circuit is equal to total voltage by resultant resistance that is equal to current through R1 is I1, that is V by R1. Current through R2, I2 is V by R2. Current through R3 is V by R3. V by R1, V by R2, V by R3. Then V by R P is V of 1 by R1 plus 1 by R2 plus 1 by R3. It makes final expression reciprocal of resultant combination of parallel resultant resistance is 1 by R1 plus 1 by R2 plus 1 by R3. Now let's answer the simple questions. Why does resultant resistance in series is more? It can be answered like this. In series combination, as resistors connected end on end makes the length of the circuit more. Length of circuit becomes more. Due to this, resistance depending on the one of the factors is the length. Resistance directly proportional to the length. Due to this, more resistance in series combination. Next, why does current same in series? In series combination, only single path for the charge flow. It means no alternate path. So, current will not be divided. Why does resistance least in parallel combination? In parallel combination, circuit area becomes more. Due to this, resistance become less. Relation between the resistance and area of cross section is R proportional to 1 by A. As the area of circuit more in parallel combination, resistance become less. Next, why does voltage same in parallel combination? Ends of all the resistors and terminals of cell are common. I mean, in parallel combination, all the resistors connected between two common points, at that common points, terminals of the cell are connected. So, voltage of the source is taken as voltage across each resistor. Voltage across the cell is taken as voltage across each resistor.